All right, we're going to take a look at how to factor a quadratic expression and use it to solve a quadratic equation. So the first thing you want to do is take a look at this constant, negative 18, and decide which two numbers multiply together to make negative 18. Well, so one possibility would be positive 18 and negative 1, and another would be negative 18 and positive 1. So you have combinations of 18 and 1 with opposite sign. You could have combinations of 9 and 2 with opposite sign, or 6 and 3 with opposite sign. And so then what you want to do is look at the coefficient of the x and decide which of these numbers would add together to make 7. So you look at the last number, the constant, and say which two numbers multiply together to make that constant. And then you look at the coefficient of the x and you say which of those would add together to make positive 7. And you can see of the examples that we have written up here, that if you used positive 9 and negative 2, that would do it. And so what that means is the factored expression then would be x plus 9 and x minus 2 equals 0. Now you can double check if that's the case by kind of going backwards and doing FOIL to multiply these together. And you can see x times x would give you x squared. Negative 2x plus 9x would give you 7x. So the outer and inner terms would give you this central term with the x. And then the last terms would be 9 times negative 2, which give you minus 18. So this is properly factored. Well, so then now that we've taken it this far to actually solve the equation, this will be 0 if either x is negative 9 or if x is positive 2. And so that would solve the equation. So let's follow this process again with another example. Here's x squared minus 2x plus 24 is 0. Again, what you do first, or can do first, is look at this constant term and think about, well, what two numbers would multiply together to give you that constant of positive 24. And so you could have 24 and 1 where they're either both negative or both positive. 12 and 2 would do it. 8 and 3 is also 24, 8 times 3. And 6 times 4 is also 24. So those are the numbers that multiply together to give you positive 24. And then you have to say, well, of those combinations, which combinations would add together to give you negative 2? And so you can see, well, this is going to be a likely candidate involving the 6 and the 4 because they're 2 apart. And so if you use negative 6 and positive 4, that will do it. And so then this is then your factored expression. X minus 6 times x plus 4 is 0. So it's properly factored. And then to solve, well, if either the x is 6 or the x is negative 4, that would solve the quadratic equation. Let's use this process one more time, one more example. You notice what's different in this last example that we're going to do here is there's now a coefficient on the x squared, where there wasn't one before in the other examples. So one way to handle these is just to divide both sides of the equation by 2 to get rid of it, or to simply pull out a factor of 2 from every term. So I'm actually going to go with that second approach. So let's go ahead and pull the 2 out of every term. And so then you pop the 2 out, be 2 times x squared minus 2.5x minus 3.5. Whether you write these as decimals or fractions depends on your style of your teacher. But I'm just going to leave it like this here. And what I like about doing it this way is then I can follow the same process that we just followed, where you look at the last number and say which two numbers would multiply together to give me negative 3.5, and which numbers would add together to give me negative 2.5. And so what you're going to find out is that negative 3.5 and positive 1 would do it. And so what that means is this expression properly factored would look like this. And so then to finally solve this thing, then you could see that this equation would be true if either x were positive 3.5 or if x were negative 1. So that would be the solutions. Now you notice what I did here was if you, depending on the form of your answers, let's say in your textbook, they might not like you leaving things with fractions or decimals. And so then in that case, you could just redistribute the 2 back in here and leave the factored expression like this. And so that's a properly factored version of this expression, 2x squared minus 5x minus 7. As an alternate approach to this, rather than, say, pulling the 2 out, another approach would be to just leave it in there and try to factor it that way. And so what another style you'll see with this is to break this down to look something like this. You'd say, okay, well, these two factors would look like this. You'll have 2x plus a constant or x plus another constant equals 0. And you can see that these first two entries are going to work because 2x times x will give you 2x squared. And then we can kind of follow the process that we did before, where this constant term of -7, you need two numbers that would multiply together to give you -7. Which two numbers would multiply together to give you that? And so what we need here then is a times b would be -7. And then likewise, we need to look at what happens with the coefficients of the x. And so that would be like the o and the I term from FOIL method. And so if you look at the outer and inner terms as you executed FOIL on this thing, you would get, well, 2b times x would be your outer terms, and a times x would be your inner terms. So 2bx plus ax is going to have to equal -5x. And so if you divide out the x, let's say, then you can see that 2b plus a is going to have to be -5. Well, then using this idea that b has to be -7 over a, you can substitute this in. And so you'll get this equation here on the left. And so really what you're doing is you're using two equations for two unknowns. We know that AB needs to be -7 because the last two terms multiplied together need to be -7. And you know that the outer and inner terms, when you use FOIL method, need to give you -5x. So 2b plus a equals -5. So you're really using ab equals -7 and 2b plus a is -5. And you're just solving two equations for two unknowns at that point. So if you solve this using b as -7 over a and substitute that in, you'll get this equation that only has the a in there. And then what I've done is multiplied every term by a. So you'll get -14 plus a squared plus 5a is 0. I'm just going to rearrange a little bit, and you'll see that we got another quadratic that we could solve by factoring. And so what you do is you say, well, what two numbers would multiply together to give you -14, but add together to give you +5? And so that's going to be a +7 and a -2. And so this would factor to look like this. And so you can see this a value is either going to be -7 or +2. And so if it's -7, using a times b equals -7, you can see that b is going to be 1 in that case. So in that case, it would factor in this way, where the a is -7 and the b is +1. And so that's a properly factored version of this expression. The other option, though, is a is +2. And in that case, since ab is -7, your b is going to be, well, -7 over 2 or -3.5. And so another equally good way to factor this would look like it would have your a value being 2 and your b value being -3.5. So both of these are equivalent ways to factor this expression. And so in either case, then, you can see that, well, these expressions would be 0 if either the x is +3.5, or if the x is -1, and so that would solve the quadratic. So that's just another way to look at how to factor a quadratic.